Hello, everyone. Welcome to the Number Sense Intermediate Class Open House for Momentum Learning. I hope that most of you who are attending this open house will hopefully have a better understanding of how this class is going to go and hopefully sign up to take the class. So what is this class? Okay, so first, an introduction about me. My name is Justin. I've been participating in a lot of math contests since I was in elementary school, and I've won many awards in number sense and things for like TMSCA, UIL, Mathleague.org, and I've also competed in math counts like the AMC series and ARMO. So noticeably, I've won a lot of competitions for number sense. I've usually placed highly in most meets that I've went to. I guess my biggest accomplishment is I've won the UIL 6A math state meet and I placed third place in number sense. And I've also been to many TMSCA states and also placed well in them. And in my free time, just a fun fact about me, I like to hang out with my friends a lot and I like to listen to music. So yeah, that's just me. At the end of this open house, if you decide that you want to register for this class, process of registration is pretty simple. So what you want to do is go to momentumlearning.org, go to their website, and on the top middle of their website, you'll see a tab called 2024 Spring. If you click your mouse on 2024 Spring, go down to online. Then once you click online, you'll see many more options. If you click school math and scroll down a little bit, you'll see the course Number Sense Intermediate. And you can click on Number Sense Intermediate for more details. And then also you'll be able to register for the class. So that's just if you guys want to register or didn't know. And then finally, what are we going to be learning in this class? So essentially, it's exactly what the class title says. We're going to be learning a lot about number sense in this class. So in case some people are unfamiliar with number sense is basically really fast mental math. In this class, we're going to teach a lot of techniques and tricks to be able to solve math problems quickly mentally. So without using paper or a calculator. So you're going to have to figure out how to do a lot of mental computation, computational estimation, and yeah, just a lot of mental math skills we're going to be learning in this class. And you may ask yourself, well, why is mental math so important? Well, mental math will not only help a kid just improve their general knowledge of math in general, but it'll also help your students, kids in math classes, just in school, and also in math competitions in the future if they want to participate these and do well. So mental math will show up everywhere in the future for these kids. Again, like I said before, in this class, we do require all students to keep their cameras on to encourage participation, to make sure everyone's paying attention. As you can see here, we have a list of topics that we're going to cover week by week. So these topics will introduce things like prime numbers, LCMs, geometry, percentages, so on. A general scope of tricks or tips that can help a student cover mental math. Does anyone have a question so far about any of these topics? And feel free to unmute or just send a message in the chat if you have any questions. Perfect. Some parent just asked me, how do we know if your kid did the homework? So in this class, again, we do have homework. It's mainly based on sort of an honor code. So we will post the homework on Canvas and we'll also post the solutions. But we really want our your kids just to print out the homework on Canvas and make sure it's done by the start of the next class. And at the beginning of every class, we're also going to do a review of our last week's material. So usually we can gauge if a kid did their homework or not based on how well I guess they did in the review, because the review is usually just questions from the homework. So let's move on to our next topic. So again, number sense is a lot of memorization and practice. And the only real way that you can get good at number sense or mental math is to learn and recognize the tricks and tips and then perform the rules and tricks accurately and quickly. So we want every single practice to be under a time limit, which is why usually in this class, we're going to assign some homework. We want you to time your homework, as well as usually in class, we might take a practice test in the middle of class, and we'll always time those as well, so that each student gets a lot of practice with performing these tricks under pressure and in a time limit. Since this is the intermediate class, we do want students enrolling in this class to have some basic number sense knowledge. So we want them to be at least a little proficient in some mental math. For example, simple FOIL, two digit by two digit FOIL, I'd say it's pretty important for this class. But yeah, just basic number sense knowledge. Number sense practice has many impacts. It can help your student in basically every aspect of math, because if you learn how to do mental math quickly, many of the operations that before might have taken a lot of time will become very quick. We would say that number sense is really important for a kid's math abilities in general. Just a quick question. How many people, like just by a raise of hands or something, a message in the chat, how many of you guys are from Texas? Okay, so yeah, some people are, okay, I guess a few people are from Texas. The main term number sense was coined because of the number sense test that is in Texas. Mainly, if you want to take number sense tests, you'll usually find the most opportunities if you live in Texas. And that's not to say that if you live in any other state that you won't find number sense. Because mathleague.org, for example, their competitions in elementary school, they do offer a number sense test with every competition. But if you live in Texas, the two main sources of number sense tests will be in TMSEA, which is for Texas elementary schoolers and middle schoolers, and in UIL, which is for high schools in Texas. They have number sense competitions as well. So if you want real experience with competitions, again, if you live in Texas, you can find it through TMSCA, UIL, or mathleague.org. But if you don't live in Texas, then your only real option, just mathleague.org. Homework. So like I said before, we do have homework. We will post it on our Canvas page every week. It'll be in the form of a PDF. Usually it'll be around 10 to 11 pages, and we expect students to do around 2 hours a week. But again, that's just a rough estimate. Depending on how fast or proficient you become at the trick, the homework can take a lot less time, but sometimes it could take more time. So again, homework's more of a honor code system. Like usually, we can tell if you have been doing the homework or not, because usually in the past, we've noticed that students who did their homework usually would perform better in the review and just overall in the class. Number sense is all about practice and applying your tricks and rules quickly. So homework is very incentivized in this class. Before we move on to an example trick in this class, is there anyone who has any questions up to this point? Okay, so now we're going to move on to an example of a normal class. We're just going to learn a simple trick or rule right now, and then it'll just be a demo of how class would usually go. First thing that we're going to learn about is how to find the sum of the terms of an arithmetic sequence or an arithmetic series. So say we have the arithmetic series 32, 36, 40, and so on up to 52, and we want to find the sum of the sequence. In other words, we can rewrite our terms as A1 plus A2 plus A3 plus AN equals SN. Go over some basic definitions. A sub 1 is equal to the first number in our arithmetic sequence. And we define A sub n to be the last number in the arithmetic sequence. And any number in between, so A sub 2 or A sub 3 is exactly what it sounds like. A sub 2 will be equivalent to the second term in the sequence. A sub 3 is the third term. A sub 4 is the fourth term, and so on and so forth. So you'll notice that in total, we're going to have n terms in our sequence, where n is the number of terms we have. And again, that's also how we defined it. If A sub 1 is the first number in our sequence and A sub n is our last number, we'll have 1 through n numbers in our sequence, or n terms. And finally, our last definition is S of n, where S of n represents the sum of the terms. So the formula that we want to use in order to solve this is going to be S of n, but the sum of the terms is equal to the number of terms in the sequence multiplied by the sum of the first and the last term divided by 2. So in a minute, we'll get to the actual derivation of how we get to this formula. But for now, all you have to know is the sum of the numbers in a sequence is equal to the number of terms in the sequence multiplied by the average of the first and the last terms. So again, let's go through one more basic definition before we go on to our derivation. So a sub n, so the last term in the sequence is equal to the first term in the sequence plus the number of terms minus 1 multiplied by d, where d is equal to the common difference. Okay. So again, if you guys are familiar with arithmetic sequences or series, you would know that each term in an arithmetic sequence will increase by the common difference. So in this case, our arithmetic difference is our common difference is equal to 4, because every time our numbers in the series increasing by 4, from 32 to 36, from 36 to 40. So we know that our common difference in this case is equal to 4. So y is the last term equal to the first term plus the number of terms minus 1 times the common difference. Well, you see that every time we increase our series by the common difference. So from a sub 1 to a sub 2, we increase by d. From a sub 2 to a sub 3, we increase again by d. From a sub 3 to a sub 4, again, d, and so on and so forth. Until finally we have a sub n minus 1 to a sub n, we increase by d. So in total, in order to get from the first term to the last term, we have to increment d n minus 1 times, which is why we get this formula right here. So since every time we add a common difference, we have to add the common difference n minus 1 terms to get from the first term to the last term in the sequence. Okay. So now let's get on to how we actually get there. So let me remove this. So now let's get onto the proof. So as you may recall, we came up with the formula S of n equals n multiplied by a sub 1 plus a sub n divided by 2 on our last slide. So how do we actually get to this? So how are we going to do it? So let's start with the general formula. S of n plus S of n is equal to 2 times S of n. So hopefully this statement should seem obvious to y'all, because if you add the sum twice, you get 2 times the sum. So now let's look at it column by column. So again, we know that S of n is equal to the sum of all of the terms in our sequence. So again, if our terms of the sequence are A1, A2, A3, A4, and so on, up to A sub n, we know that the sum is just going to be the sum of all of these. But now let's figure out a way to rewrite A sub 2. So again, using our common terminology, we know that a sub 2, or the second term in the sequence, is going to be the first term in the sequence plus the common difference. So in other words, a sub 2 is equal to a sub 1 plus d. In similar terms, we would know that a sub 3 is equal to the first term plus 2 common differences, and so on and so forth. So the fourth term would be a1 plus 3d, the fifth term would be a1 plus 4d, and so on and so forth. And again, we would add up all our terms in the sequence until a sub n, which again we previously defined as a1 plus n minus 1 times d. We know that a sub n minus 1 would be a1 plus n minus 2 times d. So now we again know that this is all the terms in our sequence. So we go from A1, A2, A3, A4, A5, so on and so forth, A sub n minus 1, and A sub n. So this is one of the SNs. Now let's look at our second SN term. So this time, instead of going from front to back, we're going to add the term from back to front. So let's, instead of adding A1, A2, A3, A4, let's add AN minus 1, AN minus 2, ... all the way to A2, A1. So again, we define AN to be A1 plus N minus 1 times D. AN minus 1 is A1 plus N minus 2 times D. AN minus 2 is A plus N minus 3 times D, so on and so forth, all the way down to A2, which is A plus D, and then A1, which is just A1. So again, this is just the exact same as the first S of N, except we flipped it. So now let's look at why we flipped it. So now if we add these two columns together, so if we add the two S of N's together, so let's do that. We have A1 plus A1 plus N minus 1 times D. If we simplify this, we would get 2A1 plus N minus 1 times D. If we go to our second pairings, if we add A1 plus D plus A1 plus N minus 2 times D, we see that it simplifies to 2A1 plus N minus 1 times D yet again. If we go down to our third term, if we add A3 and AN minus 2, we would have A plus 2D plus A plus N minus 3 times D. And again, the sum comes out to 2A plus N minus 1 times D. If we keep doing that, we figure out that every time we add our two S of N's together, we'll get the same sum, 2A plus N minus 1 times D. So if we look down here, if we add these two terms together, we get 2A plus N minus 1 times D. If we add AN and A1, yet again, we get 2A1 plus N minus 1 times D. So now we have a formula that we can write. So we know that since in total there's n terms in our sequence, there's going to be n sums of 2 times A plus N minus 1 times D. So if we rewrite that as n times A1 plus A1 plus N minus 1 times D is equal to, and remember that these sums all sum together are equal to 2 times this number, 2 times the sum of the series. So we can rewrite this as 2 times the sum of our series. So now if we do some arithmetic rearrangement, again, we recognize this part of our sequence or of our equation. We previously defined A sub n to equal A1 plus N minus 1 times D. So now if we substitute this into here, we can rewrite this as n times A1 plus AN is equal to 2 times the sum of the series. So now if we divide everything by 2, we would come out to the formula. The sum of the series is equal to the number of terms in the series multiplied by the first term plus the last term divided by 2. Okay, so that's how we got to our formula. So yeah. So now that we understand how our formula works, let's go back to our previous question and figure out the sum. So if we go back to our previous question, so right here, so now let's do the math. So again, we know that the sum of our terms in the sequence is equal to the number of terms multiplied by A1 plus AN divided by 2. So in this term, we know everything but one thing. So we have A1 defined as the first term. So we know that A1 is equal to 32. We know that AN is defined as our last term. So you know that AN is equal to 52. So in order to find our sum, we have everything we need except for n. Again, remember that n is the number of terms in our series. So how do we find n? Well, the answer is we have to rearrange this equation algebraically. So if we have an equals a1 plus n minus 1 times d, if we subtract a1 from both sides, we get an minus a1 equals n minus 1 times d. If we divide both sides by d, we have an minus a1 divided by d equals n minus 1. And finally, we add 1 to both sides. We come up with the formula an minus a1 divided by d plus 1 equals the number of terms in our series. So now let's find n in this example. So we know that n is equal to an, the last term, or 52, minus a1, the first term, or 32, divided by d, the common difference. Again, previously we explained that the common difference is 4, since each time we're incrementing by 4, and finally plus 1. So if we simplify this becomes 20 divided by 4 plus 1, or 6. So now that we have n, a1, and an, so we're ready to find our sum. So S of n is equal to n, or 6, multiplied by a1, 32, plus an, 52, divided by 2. So again, this will simplify to, we cross out the 2's, 3 times 84, or 252. Okay, so does anyone have a question over this specific arithmetic sequence, or is everyone fine? Okay, if everyone is fine with this arithmetic sequence, then we're going to move on to some practice questions. So let me go pull up the practice right here. So again, usually in a class, after we explain a trick like that, we'll usually explain the motivation behind the trick, and then we'll give them usually 5 practice questions to practice the trick. And then after that, we will usually play a Kahoot. So right now, again, in case some of you guys are new to this, I'll write both formulas. S of n equals n multiplied by a1 plus an divided by 2. And we previously derived that n is equal to a sub n minus a sub 1 divided by d plus 1. So again, I'll do the first one with you guys, and then after that, I'll give you guys some time to do the rest. So we have 2 plus 7 plus 12 all the way to 22. So again, a sub 1 is defined as 2, a sub n is defined as 22. So yet again, we have a1 and an. The only thing we're missing is n. So again, in order to find n, we have to use this formula on the right here. So we have an, so 22, minus a1, 2, divided by d. So in this case, we're incrementing each term by 5. From 2 to 7, that's 5. 7 to 12, it's also 5. Then we add 1 at the end. So this becomes 20 divided by 5 plus 1, or 5. So we now have everything that we need. Our sum in this case is equal to n, 5, multiplied by a1 plus an. So 5 multiplied by 2 plus 22 divided by 2. And that's going to be our sum, or 60. Okay, so now I'll give people in the chat or like in the meeting some time to try the remaining 4 questions. And then I'll give maybe 5 minutes since this is the open house. But usually in a real class, it would be a little longer. But in this case, we'll take 5 minutes and let the kids try some of the questions. And once you're done, you can always private message me the answers. That's how it's going to go in class. And then I'll tell you if the answer is correct or not. So right now, let's just try the questions. All right, so again, for time's sake, we're just gonna get started explaining the questions now. But usually in class, you guys will have a lot longer time to approach these practice questions. But since this is just the open house, We'll go through it and explain some of them now. So again, in 1 plus 5 plus 9 all the way to 29, we have a1 equal to 1, an equal to 29. So again, we have everything we need except for n. So again, n is equal to the last term, 29, minus the first term, 1, divided by the common difference. So from 1 to 5, 5 to 9, every time we're incrementing by 4, and finally plus 1. So in this case, n is equal to 28 over 4 plus 1, or 8. So now if we plug everything into our formula, we have 8 times first term, 1, plus last term, 29, divided by 2. Or, wait, okay, yeah. So we have 120. Okay, let's move on to our next question. Again, a1 we will set to 30. an we will set to 66. Same thing as before. All that we're missing is n. So n is equal to 66 minus 30. Let's find our common difference. From 30 to 34, from 34 to 38, every time we're incrementing by 4. So if we add 1, this becomes 66 minus 30 is 36. Divided by 4, that's 9, plus 1. We have 10 terms in our sequence. So now let's plug everything in. We have 10 multiplied by a1, 30, plus an, 66, divided by 2. 30 plus 66 is 96. 96 divided by 2 is 48. And finally, 48 times 10 is 480. Let's look at our fourth sequence, 17 plus 20 plus 23 all the way to 41. Again, a1 is 17, an is 41. All we need to find is n again. So we have n is equal to 41 minus 17. Our common difference from 17 to 20, 20 to 23. Every time we're increasing by 3. So we have 41 minus 17 divided by 3 plus 1. 41 minus 17 is 24. Divided by 3, that's 8. If you add 1, we have 9 terms in our sequence. And finally, our sum is 9 times 17 plus 41 divided by 2. 17 plus 41 is 58. 58 over 2 is 29. And 29 times 9 is 261. And finally, our last question, 49 plus 54 plus 59 all the way to 99. Again, we can set 49 to a1, 99 to a sub n. So again, for a formula, we only have to find n. So n is equal to last term, 99, minus first term, 49, divided by our common difference. So our common difference, in this case, from 49 to 54, 54 to 59, common difference is 5. And finally, add 1. So 99 minus 49 is 50, divided by 5, that's 10, plus 1, that's 11. So in order to find our sum, we have 11 times 49 plus 99 divided by 2. So 49 plus 99 is 148. Divided by 2, that's 74. So we have 11 times 74. And you should probably know the times 11 trick. So if you do 11 times 74, you get 418, or 840. So I know this section might have been a little fast-paced, but don't worry. Usually it'll be a lot slower in actual class. So does anyone have any quick questions over any of these questions? Okay, if not, we're going to attempt to place a little bit of our Kahoot. So we probably only have time to play maybe 2 or 3 questions of our Kahoot. But usually in every class, after we learn a trick and do the practice questions, we really encourage the students to join a Kahoot, because it's a lot of fun for the kids, and they usually like playing the Kahoot and competing a little bit. So we're going to try that right now. So if you want, you can join, go to kahoot.it and then join with the code 383426 to play. I guess we only have time for 1 or 2 questions about the tricks. So again, we usually really highly encourage students to join and participate in the Kahoots because again, it's a source of time pressure and better practice of the tricks. So I'll give everyone like a minute to join before we get started. Then we'll play 1 or 2 questions, and then we'll be done. Okay. Is there anyone in the Kahoot, or is there anyone not in the Kahoot that wants to join the Kahoot right now? Or are we fine? Am I okay? Okay. So I'll wait a little bit. Okay. Is there anyone else that wants to join the Kahoot that isn't in yet, or am I okay to get started? Okay. Okay, almost there. Okay. So is that everyone now that wants to play? Okay, we're gonna get started in 5, 4, 3, 2, 1. And again, we're only gonna play 1 or 2 questions because of the time, but usually in a real class, we'll play through the whole Kahoot. Okay, so the correct answer for this one was 392. Okay, since no one got it, I'll just explain it really quickly. So again, we can set A1 to be 35. We can set AN to be 63. So again, recall that our formula for sum was n times A1 plus AN divided by 2. So again, we have A1 and AN. We only don't have N. So again, N was equal to AN minus A1 divided by D plus 1. So in this case, AN is 63, A1 is 35, D are a common difference every time we increment by 4. So from 35 to 39, 39 to 43, we're incrementing by 4. And finally, add 1 at the end. So this becomes 28 divided by 4 plus 1. So we know that we have 8 terms in the series. So now let's plug everything into our formula. So we have 8 terms multiplied by first term 35, last term 63, all divided by 2. We know that 35 plus 63 is equal to 98. So if we cancel our 2 and our 8, we have 4 times 98, and we know that 4 times 98 is equal to 392. Okay, so it's okay that no one got it since this is still like an open house and it's a pretty tricky like topic to learn, but yeah. Okay, so we're actually going to play, I guess we can play one more question and then be done. So really quickly, one more question. Okay, so the answer to this one was negative 118. So again, no one got it, and that's fine because this is one of the most tricky topics that we might cover. We don't learn this one until pretty late in the actual unit. So yeah. So okay. So I think we're going to end it there. So again, if you're interested in the class, you can go to momentumlearning.org. And again, the registration details are right here. So again, you go to 2024 spring, online, then school math. You scroll down a little bit and you can find number sense intermediate. Again, this is all on momentumlearning.org. You can also call the office phone at 281-277-9075 if you have any more questions, or you can email info@momentumlearning.org if you want to email your questions. But that's it for our open house today. Thank you guys all for coming out today and participating a lot. And don't be scared if you felt like this was a little bit too hard. This was a pretty difficult topic. So if you feel like you want to learn the class, I hope you guys sign up and I'll see more of you guys in the actual class. So again, that will be all for it today. So you guys can leave if you want, but if you have any more questions, you can stay behind and I'll feel free to answer them. So if you don't have any questions, bye everyone. And again, thank you guys for coming. All right. So do any of you guys have questions? Yeah.
So how do you do it fast enough that you can like
Oh yeah, okay. So yeah, that's like a pretty important part of number sense, I guess. And again, like the only real answer I have for you is like a lot and a lot of practice. So like I know it may sound like pretty cliche to say that, but in reality, like that's the only way you're going to be able to get fast, and it's just a lot of practice. So that's why like we do a lot of practice in class, like we do the Kahoots, and we also have the homework. So it'll just help you. Like if you do all of those, you should have enough practice to get faster as time goes on. Yeah. But yeah, I know at the start, like it'll feel hard for everyone, but that's just part of like learning math. So, yeah. Right. So does anyone have any more questions? No one has any more questions? I'm going to end the meeting. So last call for any questions from anyone about anything. Okay. No one has any more questions, then I'm going to end the meeting for everyone. So again, thank you all for coming
Excuse
to the
me.
open house. I hope you guys show up. Oh, is that a question?
Yeah, sorry.
Yeah.
Would you be to share the slides? Sorry.
Oh,
I
yeah.
just
Do you just want me to go through them really quickly?
yes.
Okay. Oh, and I'm pretty sure this will also be posted on the Momentum Learning website. But yeah.
Okay.
Okay. So again, this was the Number Sense Intermediate Open House. This was an introduction about me. So again, my name is Justin. I've been participating in math contests for a really long time, won many awards in number sense. So I'd say I'm pretty qualified to teach this class. Because I've been doing number sense for almost 10 years now. So yeah. And then again, this is just a quick student introduction, how to register for the class. So you go to 2024 spring, click online and school math. You scroll a little bit down and you'll find the number sense intern class. You can click on that for more class details, and you'll be able to register there and find more info. This is just a quick schedule of how our class is going to look. So the tricks that we're going to learn week by week. And again, why number sense is so important for kids. Again, because since number sense is all mental math, students will need mental math for however long they learn math for. So not only just school math classes in college, but also for math competitions if they want to compete. Number sense will be really important. And I guess an important thing to notice is that if your student does decide to join the class, we will have to have them have their camera on throughout class just to make sure like everyone's paying attention, and that yeah, just basically to make sure all kids are paying attention. So again, number sense is a lot of memorization and practice. Like, and if you want to get good at number sense, you have to learn the rules accurately and then learn them quickly. So first in class, we're gonna practice doing them accurately, and then the Kahoot and then the homework that we give will be to train them how to do it quickly. And we'll also take a lot of practice tests in class under time limits to make sure that everyone gets enough practice. And again, since this is an intermediate class, we do want students enrolling in class to have some basic number sense knowledge. So I guess an example that I gave earlier was they should at least know how to be able to FOIL 2 by 2 digits. And then again, if you live in Texas, the ways that you can take number sense competitions are through TMSA contest or UIL, which is for high school. TMSA is for elementary or middle school. Or if you don't live in Texas, or even if you do live in Texas, you can always do mathing.org, which is for elementary schoolers. They offer number sense like tests for every competition. So if they want actual number sense experience, they can go to one of these 3 competitions. And then the homework, again, homework will be posted on Canvas every week. It'll be around 10 pages, I would say. So again, homework's in honor code. We really want them to spend around 2 hours of a week. But if someone gets really proficient with the trick, it could take them maybe an hour. 2 hours is just a very rough estimate of how long each person would take. And then finally we explained like a quick trick in class. So I gave them like a demonstration of a trick that we would learn in class. So here I guess some of the terms of an arithmetic sequence. And then usually after we explain a trick, we'll explain how the trick works. So in this case, we gave a proof of why our formula works. We went back to the actual question, we solved it. And then after every trick or question that we explain, we'll give 5 practice questions for the kids to do. We'll give them some time to work on the questions. And then while they're working on the questions, they can private message me the answers to the questions, and then I'll check them. And then after the practice questions, we will play a Kahoot. So the Kahoot will usually be around 10 questions. We really encourage every student in the class to join the Kahoot, play along with their friends. Usually the kids really like doing the Kahoots because I guess it's sort of a mini competition. And then it also gives you a time aspect to it, which is really important for number sense. And yeah, that was it. So if you have any questions, you could go to momentumlearning.org. You could call them at 281-277-9075 or email them at info@momentumlearning.org. Okay. Is there anything
Thank
more that you want me to explain? Or
oh, thank you so much, Justin. This
okay,
is
yeah.
very helpful.
Thank you for coming too.
Thank you.
Okay. Yeah, no problem. Okay, so does anyone have any more questions? Okay. So if no one has any more questions, I'm going to end the open house now. So again, thank you all for coming and staying for the end of the open house. But yeah, have a nice weekend, everyone, and hopefully I'll see you guys in class.